Hi and welcome. It's Jim from Maverickstar Observatory. We don't do weather warnings here at the observatory, but I do feel I should mention something to you, and I know a lot of people are going to think, well, that's stating the obvious there, Gene, but the reason why I just want to say something about this winter is going to be a little bit different from all the others, and I think we are going to be looking at the coming weeks and months as we go through the winter in the Northern Hemisphere. I think we could be looking at a lot more snow, ice and sleet, for the reason that the Northern Hemisphere, or the Arctic Circle, has put on so much ice in just 1 year alone. As you can see, I've marked 2 bars on the lowest dip in the trough on that sine wave that we see around September. 2 marks which show clearly nearly 2 million extra square kilometres of ice that has been added pretty much in 1 year. You can see all the other years in the lower left corner that are represented by different coloured lines, that this one, the red one, 2021, has been the most progressive for adding ice into the Northern Hemisphere. And it's for that reason I believe we are looking at a major weather front that is going to last probably over the winter period, and it's going to be delivering a lot more snow and ice, and in turn causing a lot more problems for all of us over in the Northern Hemisphere as a result of that. A little bit later on, I just want to show you the temperature patterns over the Northern Hemisphere. We can also see that over the Southern Hemisphere on both the W3 chart and the standard globe that we'll be looking at, so you can get an idea of the vast sub-zero temperatures that are spread over the Northern Hemisphere at this time right now. So let's get over there. But because of this mainly, I just want to say, heads up, expect more severe weather than what you would usually get, and also this could be the start of us merging back into a glacial period. And I know there are some experts out there that would disagree with me. You can't base what we see on 1 year as any predictions, and I completely agree with that, but it is a stark, noticeable difference in the quantity of ice that has been added over in the Arctic Circle. And you're not going to be seeing this on the mainstream media, and there is obviously reasons for that, which I'm probably not going to mention here on YouTube, but probably I could do on alternative channels. And the nice thing about what we've done recently over on Rumble is set up an account there, and we've begin to see very early signs of people moving over there, which is nice and reassuring. I know the views that we're going to get on the videos on Rumble are not at this moment going to be the same as what we get on YouTube, but it will be a slow and steady progression, I guess. So let's have a look at the temperature over the Northern Hemisphere and around the other parts of the world. So just starting off over the Northern Hemisphere, looking directly down on the Arctic Circle, you can see all those regions that are blue, turquoise and purple, or magenta or cyan, whichever. You can see that these are all temperatures, if you look in the bottom left hand corner when I just click on them, sub-zero temperatures. I mean, at that point there where we are, I believe over Siberia somewhere, in the Arctic Circle, it's minus 37 degrees Celsius. Extreme cold, but not uncommon for this time of the year. But what we are seeing is this extend, when you look at it from a point of view where we can see the equatorial region and we go over, what you will see is this extending further south towards the equatorial region, covering most of Russia and going into China. Now you might think, well, this is not uncommon for this time of the year, but there is something I just want to make a point of here, and I think I can bring that point out a little bit clearer. I'll just first of all go around, the globe, so you can see the extent of those sub-zero temperatures in the Northern Hemisphere. And remember, we are furthest away at this point in our orbit around the Sun, so that makes our Northern Hemisphere go into the winter and the Southern Hemisphere go into the summer. But what I wanted to point out here is how much on one side of the world is covered more in sub-zero temperatures, And I believe the reason for that is because the magnetic North Pole is migrating, as we know, to central Russia. I believe it's dragging the Arctic climate with it. I've said it before, I don't believe that the Arctic Circle has, sub-zero temperatures, rotational axis and magnetic North Poles all there in that same vicinity just by coincidence. I think that they all play a part in each. Up until date, I think we have started to see gradually a shift of the Arctic Circle going in the direction of where the new magnetic North Pole is travelling, and that is towards Russia. And as a result of that, I reckon that's why we're seeing the continent go a little bit cooler as well. I think if I put it on the W3 map, you get a clearer picture as to what we're talking about with regards to that. So what I'll do, I'll just stop it here and then I'll realign the screen so that it fits the whole of the globe in for you. You can probably understand why I say that if you're above 40 degrees latitude on our planet in the Northern Hemisphere, it is going to start to become more difficult as we move more into that elliptical orbit in the years to come. And we're already seeing, well above 40 degrees latitude, sub-zero temperatures, which are going to be extending those winter seasons over the Northern Hemisphere. And during glacial periods, it's not uncommon for those temperatures to remain where they are right now, covering those continents that they are all year round. And again, it's not uncommon for you to go into the Arctic Circle in the summer and experience temperatures of 10 degrees. Remember, the only difference between a glacial and interglacial period is a temperature variation of around about 8 degrees. And you can see why I am saying that we could see mass evacuations in some countries, because I just don't see how people are going to be able to produce crops. You can see a lot of Europe is covered. The United Kingdom during the last glacial period, pretty much down to around 50 degrees, was covered in glacials. New York was covered in glacials. So what I'm saying is I think we may have been a little bit foolish by thinking to ourselves that we can occupy this territory, build our cities. But the point is, as we've seen, these cities are not sustainable. And even after a couple of weeks of bad weather, what we've seen in Canada with the floods over the last month, washing away rail lines and major road networks, leaving Vancouver Port blocked and cut off from moving those goods out. We're talking about tens of millions of pounds worth of goods, lots of crops from all over the world. And when that sort of thing happens, and I was reading an article as well where they said one of the problems that they're getting is compounding problems, where one event happens, like the roads get washed away, the railway foundations beneath the railway get washed away from underneath it, they get it repaired, and as soon as they get that repaired, another major incident happens. And this is what's going to be grinding down governments in these northern hemispheres over the coming years, because they simply are at some point going to have to abandon some cities, maybe even some of those territories that are occupied right now. It is going to be extremely hard for countries in the northern hemisphere to feed the people and the population within those countries in the foreseeable future. And you can just see why I say that. I wanted to show you these two variations. First of all, on the left we've got temperature, on the right we've got magnetic intensity over the world. But if you look at the northern hemisphere, you'll see that they're very similar in the pattern that they form. Now, this is why I say I believe that we could be seeing a slow migration of not just the magnetic North Pole towards Siberia or Russia. We could also be seeing those Arctic temperatures move along with it. This temperature chart was taken a few years ago, and I've used this a couple of times as examples. You Yes, the Southern Hemisphere tells a little bit of a different story, but if you look at the temperature of the Southern Hemisphere compared to that big magnetic intensity which is just creeping up on the South Peninsula of Australia, what you'll see is that the intensity is around 60,000 nanotesla and the temperature is probably around 30-40 minus degrees Celsius in that same region. But over the Northern Hemisphere it's more apparent. If we look where the United Kingdom is, right where we've got Trimag on the right hand map, you'll see that the magnetic intensity between those two major plumes is less. It's no coincidence that when we look at the temperature, that the temperatures are warmer in these regions. So, you know, I might not be too far away when I suggest that the higher the magnetic intensity is, the more colder it's going to be in that region. And that's why I say I don't think it's a coincidence that over in the Northern Hemisphere we have the rotational axis, the magnetic North Pole, and also the Arctic climate. And I think that this pattern does give us some indication of that. One thing I will say is if you look at the magnetic intensity chart on the right hand side, you'll see it's a little bit darker. That's because it's probably 5,000 nanoteslas more stronger in that region than over in Canada. So you're probably looking at 55,000 nanoteslas over the intensity over Canada and 60,000 nanoteslas over Russia. But we know the magnetic North Pole is being won by Russia over there, and it is taking that magnetic North Pole over the Northern Hemisphere. The reason why we've got the compass pointing in between the two is, as I've shown in experiments before, if you get two magnets and put your compass in the vicinity of those two magnets, it's not going to point at either one. It's going to point directly over the region in between the two magnets, and that is exactly what's happening. You see, people think our compasses are pointing at the magnetic pole. It's not. It's just pointing at the intensity between two poles. You know, I've suggested that we have 4 poles on our Earth at the moment, and that is why we're looking at 4 increased regions of our planet where the intensity is at greater levels. So again, I'll just try and illustrate those a little bit more clearer using the magnetic intensity map on the right, and then the top left you've got the temperature, and then on the bottom left you've got the magnetic intensities around the world. But the circled areas are all the same, and I think the point where I'm trying to come across here is that, you know, temperature, I believe, is definitely linked to the intensity in magnetism, something you're not going to hear on mainstream media being talked about for some reason, or by any other institute. I don't know why they've not drawn the same conclusion, but you know, you can see quite clearly with the arrow that just points up directly to where I was saying is the weakest intensity of magnetism, but it's also on the temperature chart one of the warmer regions. And then you've got your 2 Canadian and Russian high intensities over the Northern Hemisphere, and then on the temperature chart you can see that these are the coolest regions on the planet. I don't think by any coincidence it's because that's just the way it is. I think what's regulating those temperatures is a migrating magnetic North Pole. One of the other things that is going to increase the chances of the more severe weather is further weakening of our magnetosphere. And as our poles approaching possibly a theoretical point of 40 degrees, which we talk about a lot about on this channel, we could see the magnetic North Pole migrate from those strong field lines which it's in at the moment, which allows it to migrate slowly into the weaker field lines. And when that takes place, obviously the magnetosphere's strength is going to come down, and we're going to be susceptible to more radiation. One of the things I would like to do, if I get a bit more time, is just look at, you know, see if we can find some statistics on actual cancer rates increasing, and see if we can compare that with that last accelerated point of around from the 1990s to the present day. I'd love to know if cancer rates have shot up over that period of time. So there you go, guys. I'm going to push off, end the video here. Just want to say you can follow me over on Rumble. I'll put a link down there in the description for you. Just click it, you should end up on one of my videos on Rumble. You know, if YouTube do start cutting and pulling more of our videos, they'll we'll just put more and more over on Rumble. Other than that, there's a link down there if you want to help support us, what we do at this observatory. We're trying to keep people informed. Not been proven that easy more recent weeks as a result of the world changing which we live in, democracy being attacked, our freedoms coming under threat, and we're seeing a lot more of these companies more ever silence people that are just trying to inform others, even if it is on the topic of weather. Guys, links down there if you want to help support us. Big thanks for those that have already, and I'll say what I usually do. Bye for now.